Hello, welcome to another tutorial series on Java Fundamentals. My name is Lawson Luke. In this video, we'll be taking an in-depth look at the Java programming language, both from the beginner to the advanced stage. And we'll be using NetBeans IDE as our work environment. If you don't already have it, you can download it from their website. I'll put the link in the description. So let's begin. This is NetBeans IDE, as it appears here on the screen. So for starters, we'll look at what Java programming language is all about. Java is a programming language and computing platform first developed by Sun Microsystems in 1995. It is a high-level programming language, which means that its commands can be read and understood by humans as opposed to low-level programming languages, which utilizes binary and combinations. It is robust. Robust as it applies to programming language has to do with reliability. And although it is really debatable whether any programming language can assure reliability or not, Java puts a lot of emphasis on error checking, like checking for possible errors, as Java compilers are able to detect many problems that would first show up during execution time in other programming languages. So Java is able to catch errors during compilation as well as during interpretation. So we'll say Java is a robust programming language. It is also a secure programming language as well. It is platform independent, which means that a Java program can be run and compiled on one system, can be compiled on one system, and then it can also be that same program can also be run on other systems regardless of the operating system that is at work in both of the systems. It uses a feature called WORA, that is WORA, write once, run anywhere, which means that if I write a Java program in a Windows laptop, I can still execute that Java program in a MacBook as well. So provided I have the JVM Java Virtual Machine installed on my computer. Okay, so we're looking at fundamental building blocks of a program. A program is a list of unambiguous instructions meant to be followed by a computer. There are two basic aspects of programming. We're looking at data and then we're looking at instructions. For data, we have variables and then we have types. For instructions, we have control structures and then we have subroutines. Control structures has to do with control and direction of your program, and it usually comprises of the if-else statements as well as loops. Subroutines are a sequence of instructions that can receive data, process the data, and return a value. A variable is a container that can hold data. So virtually all programming languages utilizes the variable feature. It is a memory location that has been given a name so that it can easily be referred to and used in a program. The type indicates what sort of variable a data can hold. So we're looking at variables, and then we have the type of variable. So when we declare a variable in Java, we need to tell the variable what type of data it should hold and what type of data it can't hold. We have 8 primitive data types in Java programming language. We have the byte, which has a minimum of these and a maximum of 127. We have the short. This is an integer as well. We have an integer or int. This is 32-bit sign. This is the maximum value, and this is the maximum value. This is the minimum value for it. We have long. Long is an integer as well. Integer has to do with whole numbers. I guess numbers without decimal points. So long is an integer. Short is an integer. Int is also an integer byte. It's like a small bit of an integer value. We have floats and floating points, which has this range of values with which it can accommodate. Now, the wisdom in knowing how when to use integer or short has to do with what capacity of what value capacity you want to give the variable. Okay, so for the most part you'll be using integer. Okay, but for most reasons you could also use short. If it's a very large number, you can use long as well. It has much more capacity than int. Again, int has much more capacity than short. Okay, so floating has a good capacity as well if you want to use float, but then double has a much more wider range, than floats. Okay, so both floats and double hold decimal points. So if you want to declare a variable and you know it's going to hold a decimal point, so you indicate it as a float or a double. For the most part you'll be using double. Char holds single character, just single character, and Boolean has to do with true or false. So let's get back to NetBeans IDE. So this is a program I created. This is the name of the file. You can see Java application 1, and this is my main method here, where you can see public static void main. We have string, then we have arguments. This is my main method. This is a comment in Java programming language. This is a single line comment here where you see this to do code application. We have a multi-line comments which goes like this here. Multi-line means that it spans several lines, just like you can see. I can write this is comment here. I can also go to another line. All right, on the comment line here, which you can see. So this is a multi-line comment. This is a single line comment here. So this applies to just this line alone. Okay. So to print out outputs in Java, to print out statements in Java, we use system.out.print. Okay, then there's print line. I'm going to show you that one in a bit. Print. So here, I'm going to write hello world right here. Now I need to put my semicolon here. Now semicolon indicates the end of line here, and Java actually requires it. And as you can see, if I take it off, you can see the program. It's all underlined in red, which means there's an error on that line there. So here, so we have system.out.print. So we have hello world here. If I can compile this, you can see I have hello world here. So now you can see that it does actually take me to the next line. It prints out everything on one line, which you can see. Now notice the difference. If I put print line here, I just put ln print line, and I run this again. Now you can see here this build successful comes to the second line. So what this print line does is that it takes whatever is coming after it, it takes it to the next line. So I'm going to write something else. System dot print line here. Another program here. Now what I'm going to do, I will remove this print line and just leave it at that. But I'll run this program again. So you can see the next program is the next command here. It's printed on the same line as this one. So what this line ln tells the programming language to do is that it's to bring everything that is coming after it to the next line. So it creates a really good space feature for you. Okay, so now you can see I'm writing everything within this main method. This is a curly brace. This is a curly brace. This is a curly brace. If you click on the opening curly brace, you can see where it's ending on this IDE here. So you can see the yellow, and the yellow means that this is opened here and this is closed here. This is open here and this is closed here as well. Okay. All right. So I'm going to declare a variable like the ones we looked at here. If we go back to we're going to walk through these 8 primitive data types and declare them and print them out on the screen so that we can see how they really work. So I'm going to declare a byte variable here. We said a variable is a memory location that can hold data. So if I declare a variable, I'll say byte, then I'll give it a name. This is the name of the variable. Okay, so now here this is the name of the variable is bt. Okay, the data type, it's the byte, which you can see here, this byte. You can see it's written in blue, which means it's a reserved word. Reserved words in programming language, especially in Java, are words that are used exclusively by the program. You cannot use them to name your variable, to name your method. Okay, so they're used reserved by they're used by the program alone. So when that word is called, the program understands what it means and then it interprets that word correctly. So byte is a keyword. So we cannot use keywords to name our variable. I can say byte here like this. I have problems with the program, so I'll use bt. Okay, so this is the name of the variable, which is bt. This is the type of variable here. It means that it's holding a byte. So if you can see here, which I said byte has a minimum value of minus 128 and a maximum value of 127. So I'm going to try to assign a value here. So the process of giving a value to a variable is called assignment. So I'm going to assign a value here. You can actually assign. I can actually assign the value here. Here when I declare it, I can see 12 like this, or I can do something like this here. I can say bt is equals 12. Okay, so you can declare a variable and assign it immediately, or you can assign a value to the variable later, but then you have to assign a value to the variable before you call it. Okay, so let me show you what I mean here. Let me try to call this variable without assigning it a value. So I'll just print bt here. So now notice, you can see here it's giving me an error. A variable bt might not have been initialized. Okay, so this variable is not initialized. So initialization is a process, whereby a variable is given a value. So we need to initialize this variable, okay, here. So if I uncomment this line here, so you can see we're good. Okay, so now we don't put variables in quotation mark. Okay, we don't put variables in quotation mark. If I actually, let me print this out first so that we can see the result. Now I get 12 printed out here. If I should comment this line here, that's command and the question mark if you're on Mac system. Okay, or you can use control if you're on a Windows system, control and question mark. Okay, so then I have this. I'm going to work this out again. So I have 12 right here. Okay, so now what if I put quotation marks around this here bt, and I run this program again? So you can see it's being read as a string. Okay, it's being read as a string. Okay, not as a variable here. So you can see that's the difference. So we'll not put variables in quotation marks, as you can see. Now we'll say that the limit for a byte is 127. So let's try to assign this byte and variable something greater than 127, like 128. Okay, so you see we get error here. Incompatible types, possible losing conversion from. Okay, so I can see if I take it to 127, that works fine. Okay, so you can see each of these data types have memory capacity allocated to them. So there is a limit of value to which a byte can take, which you can see here. There is a limit to which short can take, and then integer as well, long, floats, okay, and double. Okay, so there's a limit to which they can values can be assigned to them. So I'm going to do, okay, excuse me. So I'm going to declare int here. So if you say int a is equal to 23, okay, so you can see here. So I can actually print out this one here like this, print line. So I'll say a. So I will comment this one out so that we can see the results, for this, properly. So you can see I have 23 here. Okay, so this is the way we declare an integer. Okay, so the data type, the variable name, and then the value initialization right here. So for short, just give sh. I'll give it 34. or 344. Okay, for long, like this, give it LG, and I'll give it this can actually take large values here, but for the most part, if you're just going to declare um, a very not so large integer variable, you can just use int. Okay, uh, you can just use int. So I'm going to declare float right here. I'll give it FL. So this takes in floating point 2.33. So this will be F semicolon. Okay. So for double, give this DB. And then I'll give these 3.444. Okay, like this. So you can see we have byte, we have int, we have short, we have long, we have floats, and then we have double. These are the way you declare variables. For char, char takes in single variable, single values like this. Okay, so it has to be a single value. So as you can see, okay, so char takes a single value, and it has to be within these single quotes. As you can see reading here on the screen. So we've looked at bytes, we've looked at int, we've looked at short, we've looked at long, we've looked at float, double, and char. We can actually print out this here, system.out print line. I can print out any one I want to. I can print out A here, put semicolon here. Sorry, this is not spelled correctly. Okay, so okay, I already printed out A, so already I can print out SH, for the value of short. Okay, so I get 344, which you can see here. So you can go ahead and print out the remaining ones if you're working alongside with this project. So you can print out long, you can print out floats, double, char. Okay, so you will notice for Boolean, I'm going to demonstrate Boolean later. Boolean is declared like this. Give a you say equals false. Okay, so this is the way you declare Boolean variable. In it, by default though, if you just declare a Boolean variable without giving it a value, it's assumed to be false. Okay, unless stated otherwise, it's assumed to be false here. Okay, so you can actually assign it to be true if you want it to be true. Okay, and then you can use an if else statement to check the condition of this program here, which we'll look at if else statements in subsequent tutorials. Okay, so now, like I said earlier, you can notice that string is not necessarily part of the 8 primitive data type, because for the most part it's a class on its own. Okay, it can be manipulated. It can be for instance, we can capitalize a string, we can check if the string is empty, so it has a new class operations on its own, which we will take a look at in most of them this tutorial. Okay, so for instance, if I want to declare a string variable here, I'll use string like this, give this str. So now string is a series of characters, like we looked at char variable. Char holds single character, so string is a series of character. So I can say my name is Lawson Luke here. So I'm going to print this out. I'll just print out this str here. All right, so when I run this program, you can see here my name is Lawson Luke, as you can see here. So what I mean, the string is a class on its own. It's that, for instance, I can convert this string variable to uppercase using inbuilt methods, in the Java programming language. I can do str dot to uppercase, which you can see here. I'll run this program. We'll look at this in more details probably and in another tutorial. So I just want to demonstrate how string works in Java programming. So you can see my name is Lawson Luke, all in capital letters. Okay, so you can convert everything to lowercase as well. That means this has to be in capital letter for you to see how it works. Okay, so I can easily do that here. System.out print line. I put str dot to lowercase. to lowercase. Okay, so I'm going to run this program again. So you can see everything is written in lowercase. Notice that this M here is in capital letter, but here everything has been converted to lowercase, as you can see. Okay, see there are whole other manipulations that you can do to strings, which hopefully we'll be looking at that in another tutorial. So since this is a basic tutorial and this is more like introductory, I just want to take a look at how the program beginning a program language in Java really works out. There's one more thing that I think we should look at, which is something called concatenation. Here, I'm going to write this. So you have concatenation. Okay, I hope I spelled that correctly. Now, it just means to join. Okay, concatenation means to join in the English word. Okay, in programming, it means to join two strings together. Not necessarily strings. It could be results. It could be integer. It could be whatever data type it is that you want to link together. We can link them together. For instance, I'm going to declare an integer and just call this age. We call this 23. Okay, so now I can do something like this. I can see system dot out dot print line. I can see Lawson is, I give it a space. For concatenation, the value is for Java is plus. The same thing with JavaScript as well. If you do JavaScript, okay, so it's plus. So I say Lawson is I'll give this age. Okay, so you can see the value for age that I give here is 23. Okay, so if I run this program here, so you can see Lawson is 23. Okay, so this is concatenation. So what I did was join this string and this integer variable together. Okay, so this can be as easy as you can get. It can be as complex as you can get. I can do this as well. I can add years old like this and put a full stop there. So when I run this, you can see Lawson is 23 years old. Okay, so now you can notice that I'm putting this space here so that the string can be correctly passed, with the appropriate spacing. I'm putting this here. So if I remove that and I run this again, so you can see everything will be clustered together like this. Okay, so it's the reason why I did this here. Okay, what most people like to do, something like this here, and then try to space this out like this. You try to space this out like this. So whatever works for you, as long as it's not confusing, okay. But then I'll feel that you should try to write less code as you can or as it allows you to. Okay, so you can see we arrive at pretty much the same result that you can see here. Okay, so these are the basic things for this tutorial. I think you should know. Okay, so this is declaration. Here we've looked at variable declaration. We've looked at variable initialization. Okay, so we've looked at printing out of statements. Here we don't only have print line, we have printf and print formats, and you also look at that subsequently as well. Okay, so go ahead and practice on your own and see how you can come up with. So I'll see you in the next tutorial.